Anytime that we start working with logs, there's this number that pops up. It's called E, and you're going to say, I have no idea what E is. Don't be afraid. E is just some number like pi. Pi is 3.14, at least that's what we remember, but it's really 3.1415926 with all these other decimals, and nobody ever wants to write out all those decimals. So they gave it a symbol, pi, and when you use that, you're supposed to remember that it's some big long number with a decimal that's way too long to write. Same with E. 2.71828, and that particular number with this big long decimal that never ends happens to be very useful. For example, if you put $1 in the bank and it's getting 12% interest and it only gets compounded one time, at the end of the year they give you your interest. You would start with $1. After 12 months you would have $1 plus 12 more cents. But imagine if the bank compounded it 2 times. That means at the halfway point, you get half the interest, which would be 6 cents, and then you get the other 6 cents at the end of the 12 months. Well, you're actually going to get just a little bit more money because the 6 cents here earned interest in that second part. And that's a tiny bit more, but hey, come on, it's money. Every little bit helps. So let's do it 3 times per year. Now this chunk earned interest for a long time, and this chunk was earning a little bit more. So it goes up just a little bit more. And what if every 3 months we were getting for it, so 3% here, and you would get interest on the interest, which would give you a tiny bit more. And I realize that you're getting less than a penny more, but you could multiply this by $1 million and it would matter in that case. So if the bank figured out your interest every 2 months, which would only give you 2% each of those 2-month increments, then it's slightly higher. And every month would be higher still. And you'll notice the change is getting less. We're now out to the 4th decimal before we see increase. And that's because there's this asymptote of where we're going to go if instead of 12 times, we took this as many times as possible. And using math, you can look at the patterns and say, what about infinity? Continuously getting all the interest. And that's actually how banks do it. You're getting infinitely many of an infinitely small amount, but it comes up to this 1.1274. How could you calculate that without actually trying to play with the number infinity? Well, you could use E. E raised to the power of this 12% is what gets you how much interest your bank account would have acquired at the end. So the bottom line is, whenever we start talking about things that are growing, this is a bank account example, but we could talk about growing bacteria or growing number of Wi-Fi users or the growing heat of the world with global warming. Anytime we talk about some sort of growth, E turns out to be a very helpful number in many ways mathematically. Since E is used for growth, which is often an exponential function, you can imagine logs also have a nice relationship with E. And so log to base E is a very common type of log to talk about. And it has some cool mathematical properties as far as derivatives and integrals that you would do in calculus. And so log to base E is very common. Log to base 10 is also very common because we're humans and humans like the number 10 because of these guys. Log to base 2 is another common one for computer scientists because computer scientists are often working in base 2 with those ones and zeros. So these are the most frequent logs that people like to play with. Now, if you have a TI calculator, which is probably the most common or something similar to it, they have a button called LN. That is the natural log, which is what they call the log base E. So they have a special button just for log base E because that's how common this is. The log button itself is the log base 10, and they don't really have a button for log base 2 because it's only computer scientists that like it. But the program R is different. The log in R is log base E. So obviously the people who made TI calculators in R have a difference of opinion as to which one's most common. R felt like base E was the most common, and so that's what they mean when they say log. If you wanted to do a log base 10, there's a log 10 function as well as a log 2 function to make the computer scientists happy. So in the code I'm going to show you, it's going to be pretty common for me to just use log. And that means a log to the base of this 2.71 whatever number of whatever you put in parentheses here. And that's just a number. It's kind of an ugly number. It's mathematically useful. But I'm going to show you in the next video that it actually doesn't matter which type of log you use, because you still get good answers, and as long as you know how to interpret it, you can still get the correct answers.